Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 17 and 18 and in your Unit 4 homework. So these questions are about what's called the electric field, and just a quick little oversight here. The electric field is something that you find around charged particles. All right, so here in this picture I've got a particle with charge Q right here. And if I pick a point in space right here, here's the idea. We know that if we put a proton here, it will feel a force in this direction. So the electric field is the name we give to, for lack of a better way to put this, what's putting the force on this proton, okay? So the electric field, here's how it's defined right here. It's defined as force per unit charge, so it's a number with units of newtons per coulomb. That's how you find the magnitude of the electric field. These arrows above it mean that these are vector quantities. Okay. The direction of the electric field is I like to say, the force direction on a pretend proton. What you do, if I want the electric field direction, say right here, you pretend like you put a proton there and you ask yourself, what would the force on it be? And in this example, if I put a proton here, the force would be this way on it. So that is the electric field direction. So here's how the magnitude of the electric field is defined. And I've talked a little bit now about how the direction of the electric field is defined. This is the equation for calculating the electric field due to a point charge. The field is directly proportional to the charge, falls off with distance squared. So that's my kind of review of the electric fields. I'm going to move this off to the right here. Now let's take a look at problem 17, where it says calculate the magnitude of the electric field 2.6 meters from a point charge of 5.2 millicoulombs. So we're pretending like we've got a point charge, and this is given. In the example I'm looking at, it's 5.2 millicoulombs, which is 0.0052 coulombs, by the way. And then we're talking about a distance 2.6 meters away. So let's say we're over here somewhere. A distance here, I'll call it r, of, in this example, 2.6 meters. Yours might be a different value. So the electric field vector at that point points away from this charge, because if I put a proton right here, the force direction on it would be this way. So that is the electric field direction at that point. And it can be calculated by kq over r squared. So the k is the Coulomb constant, 9 times 10 to the 9th Newton meters squared per Coulomb squared. The q is the charge given in the problem. And the r is also given in the problem. And then you're just going to, run those through and get a value out. That's enough on 17. We'll take a look at 18. What magnitude point charge creates an 18,000 Newton per Coulomb field at a distance of 0.25 meters? So I'm just going to use my same picture. The only difference is that, whoops, there we go. The charge is not known in number 18. This is the unknown. But the problem is basically the same. They give you some other distance. In my example, it's 0.25 meters. Yours might be different. They give you a field strength, so the E is given, the K is the Coulomb constant, the R is given in the problem, and you're solving for Q. So that should get you through 18. I hope that this helps. Have a great day.